Hi, welcome to Pattern Recognition video presentation. I am Shondivan Chakraborty and I am going to present the entire video presentation. So, what is pattern recognition? Pattern recognition is a branch of machine learning that focuses on recognition of the patterns and regularities in the data. This data can be anything. It can be voice, it can be picture, it can be digit, anything. So, the next point is what is the purpose or why we will use the pattern recognition? To solve the complex problems, we are going to use these kind of techniques because the complex problems can be solved just by doing the recognizing and solving the small problems having same kind of pattern and which are basically the unit cell of the complex problem. The next point is what are the importance of this pattern recognition? Pattern recognition identifies and predicts even the smallest of the hidden and untractable data. Second, it helps in the classification of unseen data. It is efficient to solve the real-time problems. It helps in identification of objects at varying distance and angles. And it not only helps in prediction of the unseen data but also helps in making the useful suggestions too. It is not a rocket science. It is really very easy to learn, to apply, and to solve real life problems. And what are the application areas where we will use this kind of technique? Number one, trend analysis. The second point is natural language processing. The third, optical character recognition, visual search or facial recognition. The visual search, we can I can give you an example that in many smart search engine we can see that by observing the picture they can give us the suggestion, they can give us the search results. So in that purpose they will use they are basically using the pattern recognition technique, voice recognition, and stock market forecasting, and also sentiment analysis. We will see one optical character recognition problem, that is the digit recognition. And here we will create one project using convolutional neural network to solve this digit recognition issues or problems. So we will discover how to develop the convolutional neural network for handwritten digit classification from scratch. And we will see that what are the software and libraries we are going to use. That libraries and softwares are TensorFlow, Keras, NumPy, Matplotlib, Jupyter Notebook. Okay, and the what is the dataset? So the dataset is basically MNIST dataset where basically the 70,000 handwritten digits are provided. Okay, among them 60,000 are given for the training set example, and the remaining 10,000 are the examples for the test set. 784 features in each pixel we can observe. Not only that, each image is 20 cross 20 pixel. Okay, each image have 20 cross 20 pixel. All the images are leveled with the respective digits. It's quite natural, right? And in the next slide you can observe what is the procedure, how we will do the entire thing. So at the first, the data is divided in training set and test set. Training set is used to build the system and test set is used to check the correctness of the system or the accuracy. Okay, here you can see that training set is used to build a model. It consists of the set of images which are used to train the system. And what is the testing set? Testing set is used to test the system. It is the set of data which is used to verify whether the system is producing a right or correct output after being trained or not. So let's start with the programming, right? At the first we'll see that what is the Jupyter notebook. The Jupyter notebook is nothing but a powerful, the notebook kind of stuff where we can develop and present the data science projects. Okay, so we are going to start the programming and we are in a fresh notepad, Jupyter notepad. So let's start. We're going to import the TensorFlow as TF. Okay, then we will import matplotlib.pyplot as PLT. Then we will import numpy as np. So these are the all importing segment, and then we are going to integrate the dataset, right? So mnist equals to, we will simply call tf dot keras dot datasets dot mnist. Let's check it is connected or not. It may take some time. Yeah, it is connected properly, right? So just remove it. As I told you that this data set is already split in two segment, trend and test. So simply we will create this kind of segmentation, right? mnist dot load data. Hope it will work. Let's check. Okay, so we will see that in the x train segment, what is the value of sixth uh, element. So these are basically the tensor. Okay, a multiple dimension of arrays is called tensor. So this is tensor. So what we will do, if we check the y train value, then we will get the actual level of the value. That is what? It is 2. So that is the previously the x train 5. This is what? This is basically all the 784 features of the 2. That's 2. Okay. Now if we want to visualize, this 2 using that features, then what we will do? We will simply call plt.im show and pass that value. We'll pass this value and plt.show. Oops, I'm getting some error. uh, oh, I'm really sorry, this is not y train, this is x train. Yeah, see, this is 2. Okay, so now we are going to build the model, the CNN models. Okay, so model equals to tf.keras models, and it will be the sequential model, right? Feed and forward model. Then we are going to add using model.add. We are going to add what? tf.keras. We are going to add the first layer, that is the flatten layer, because the input layer, the first layer is basically the input layer. The input layer is obviously the flatten layer. It will be the shape of the input layer is like flat, so it will be the flatten layer. And the next layer, it will be the first hidden layer. So keras dot layers dot dense, hidden layers are specified by dense, and here we have to send some parameters. The first parameter is the number of neurons in that hidden layer. So this is basically 128, and then the activation parameter. What is the activation parameter? Activation parameter is such a kind of condition. If that condition satisfied, then automatically that specific neuron, the specific node will be activated, otherwise not. Okay, so by default activation uh, parameter is given as tf dot keras dot tf dot really sorry tf dot nn dot relu. Okay, so what is that relu? Relu is basically nothing but the rectified linear function. It basically signifies the rectified linear function. Fine. So I will simply copy this first hidden layer, and we are going to create the same second hidden layer, and then we are going to create also the third, but it's not the hidden layer, it is the output layer. And the output layer, how many neurons you need? 10, because there are 10 classifications, 0 to 9, right? And in this case, please observe, it won't be ReLU. Okay, because here in the last case we will do what? We will do probability distribution, right? So in the case of probability distribution, we will pass softmax. Okay, so this is all about the model architecture, right? This is all about the model architecture. Now we'll do what? We'll create a model compile section. The model compile section will pass the optimizer. Will pass what? The optimizer of the model, and it is the Adam, which is basically very common optimizer, the Adam optimizer, right? The second will be the loss. In our case, the loss will be sparse categorical sparse. In our case, it will be sparse categorical entropy, right? Sparse categorical cross entropy. Okay, and the second thing, the matrix, and it will be accuracy. Now our model is ready to train. Just need to pass the X train and Y train, basically the features and the level. Oh yeah, we need to send the epochs also. Yeah, the model is training. You can see the accuracy level is going higher in each case. See, this is 87, this is 92, and in case most probably it will be 90. Okay, this is 93, almost 94. Okay, so our model is completely trained. Now let's check. Okay, so you simply get one predictions, where basically predictions basically an array where we will store all the predicted values of the test set by using this command model dot what predict 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 what x test, right? Okay, so now if we check the predictions for suppose the fourth element of the test of the x test segment, then we'll get what? we're getting the we're getting what we are getting the 10 values. Basically you can see the 10 values. These all are the probability distribution for the 10 classes, 10 different classes. This is the 9.9, 3.2, 1.0. Okay, this is a 9.65. So there is basically a critical decision between 0. It is 0 or 1, 2, 3, 4, 5, 6. 0 or 6. Okay, there's a critical decision because this just see this is 9.9, this is 9.6. So the digit digit seems like some 0 or in some case like 6. But obviously 0 wins the race. 0 wins the race. So for our better perception, we'll do what? Print. We'll call numpy array for doing argmax of this stuff. Let's see. Yeah, there is 0. We can visualize also this thing by using imshow, and then x test, and we are going to test the which element? Fourth element, right? plt dot show. See, there is a 0. So this is one example of pattern recognition using what? Using deep neural network. So thank you.